Okay, here we go. Practice exam answer key. I'm just going to do this in real time. Hope I don't make too many mistakes, but sometimes that makes it a little bit more authentic. These say simplify, they do not say solve. There's no equal sign, so don't go around inventing equal signs for these things. Just be careful when you distribute. That's a -3 coming in to those two places. So it's 15x minus 3x, but plus 6 plus 25 plus 7. Sometimes it helps to like underline things that are the same. Double underline all the numbers, and you're going to get 32, 38, and 12x plus 38. That is the only simplest form of that works. Here you cannot add or subtract anything until you know they're the same type of critter. So we need to do our little breakdown here. That's 3 times 25. When we're taking a radical and putting it into simplest radical form, find the prime factors always by starting out with the smallest number. Can't take out a 2, but I can take out a 3. Can't take out another 3, but I can take out some 5s. When you get this hockey stick, look for pairs of numbers. Those two 5s, when I take the square root of 5 times 5, I get 5. I can't take the square root of that lone 3, so it stays behind in the radical. When I do the same thing to this, you can try it, you'll see that this becomes 3 radical 3. If I have 5 apples and I take away 3 apples, I get 2 apples. The radical 3's do not somehow magically cancel, they stay. Just like if it's 3x minus 2x, 5x minus 3x would equal 2x. It's the same concept. There is your one simpler answer. I have an equal sign there only because I'm saying that this equivalent statement is equivalent to that. Okay, here this is just rules of exponents. That's x to the 5th. We add those, then that's raised to the 4th. So if I had 4 of these multiplied together, I'd have a total of 20 of them. That's that solution there. Here we want to change everything to have a common denominator and then see what happens. 2 is found in 6 and 3 is found in 6, so my common denominator is just going to be 6x. That's the simplest, lowest common multiple for these things. So I'm going to multiply top and bottom by 2x here to this fraction to give me 6x. I'm going to multiply top and bottom by 3 there to give me 6x. And I'm going to multiply top and bottom by x to give me 6x. So I get 2x squared over 6x plus 15 over 6x minus 2x squared over 6x. Well, I've got the common denominator, so I can think of a single bar here. 2x squared minus 2x squared just gives me 15 over 6x. Well, I can cancel down then, take out a 3, and I'm going to get 5 over 2x is my one simplest, best answer there. Okay? This is just, do you know how to type this into your calculator? It's under the math. It's going to be the equivalent of 10 factorial all over 7 factorial, 3 factorial. I don't have that one memorized. I'll punch it into the calculator and we'll get a solution. This one I think is a little bit easier. Whoops, slight mistake here, I already caught myself. This is just 10 factorial all over 3 factorial. Be careful. Permutations, it's just the same thing as 10 times 9 times 8. The first 7 numbers, 7, 6, 5, and then 4. So that's what that will be, the equivalent of 10 times 9 times 8 all the way down to 4. This one is just like I meant to write that one. 10 factorial all over 7 factorial, 3 factorial. That's going to be the same. I can do this one without a calculator. 10 times 9 times 8 times 7 factorial all over 7 factorial times 3 times 2 times 1. That's the 3 factorial. And the 7 factorials will cancel. That's just 1. 3 will cancel with the 9 and give me 3. 2 will cancel with the 8 and give me 4. 3 times 4 is 12 times 10 is 120. But again, you can type that into your calculator. Go to the math and then the PRB menu and you'll see where that is. You type in 10, you go to math, PRB, choose like option number 3 or 4, then hit 7, then hit enter, and you'll get that. Okay, it's all about having the same base numbers, and these are all 2's. Just like up here, these were both x's. So what we do is we add those exponents. So this is equal to 2 to the x plus 3x plus x. That's all you do, but we can simplify this. So this is 2 to the 5x. That's the best simplification there. Here, remember that when you square something, you're multiplying this by itself. 3y squared times itself gives me 9y squared, so it's x to the third, 9y to the fourth then, all over 6x to the fifth and y. Well, if I simplify these, I get x squared down below. If I simplify these, I get y cubed up above, and then 9 over 6 is 3 over 2. So that is the single best answer right there for that. This one has negative exponents. The negative exponent only applies to the x, so just this part goes down below, as in just this part going up above. When you see the negative exponents, just move them to the opposite side of the division bar and then simplify. So that becomes 5y to the fourth over 35x squared x to the third. So the 5 cancels with the 35 and gives you 7 in the bottom. So this is equal to y to the fourth up above, and then 7x to the fifth down below. Okay? 6 factorial, this is a pretty simple problem, just showing you that 6 times 5 times 4 times 3 times 2 times 1, pretty simple. That's going to be 24 times 5 is 120, times 6 is 720. If you use a calculator, 6 factorial can also be found on the PRB. Alright, so that's page 1. Solving now is different than simplifying. We want to get an x that gives us a solution. If I take the square root of both sides, I get x equals 5. Now a lot of people will go on to the next problem, but don't forget it's plus or minus 5. You can have 2 numbers that when you square them give you 25, the positive and the negative. You're going to lose points if you forget that, so don't. Here, anytime you have 2 fractions set equal to each other, that's a proportion. Cross multiply. Do these guys and then do these guys. So that's 15 is equal to 4 times 3x plus 1. It does not hurt to do out the math. You get partial credit in case you make a mistake. 15 then equals 12x plus 4. Take away 4 from both sides, I'll get 11 equals 12x. So my solution then is that x is going to be equal to 11 twelfths. Don't give me decimals. It's so much easier just to write the answer like that. If you do use decimals, go round or use a bar to express repeating decimals. Here, this is given to you in factored form. Do not FOIL things and multiply. That's just making it harder. When you have something set equal to 0, either this is equal to 0, or this is equal to 0, or this is equal to 0. The only way you get 0 is if you multiply 0 by something. The only time this is equal to 0 is when x equals 2, or here when x equals a negative 5. Here, though, don't just say positive 5 because that 2x messes that up. Write a separate little equation. 2x minus 5 equals 0. Add 5 to both sides, and you'll quickly see that 2x, if it's equal to 5, that means x equals 5 over 2. So don't write 2.5. Just keep it as a fraction like that. There you go. There are your 3 solutions. You can also write x equals and then use the brackets. This is the more official mathematical way to do it with set notation. It's called. There's your solution set right there. Alright, now this one is a lot like some of the difficult problems we did in, I think, section 9-3. It's all about finding a way of clearing the fractions, and you've got to consider that this could be factored and these parts could be found in it. So we put down our little factor parentheses. The only way to get x squared is x times x. The only way to get a 2 there is a 1 and a 2, and that's a negative sign, so 1 is plus and 1 is minus. The plus goes with the bigger number, so I try that out, and lo and behold, it foils and does make this, and that is what is here. So it's like we have part A, part B, and there's A times B. Okay, so what we need to multiply by is both parts, both the a and the b parts. So x minus 1 times x plus 2. I multiply this times this, and this whole denominator cancels with what I'm multiplying it by, and I get just 5x. Okay, I'm multiplying this times this. If you need to write this 3 times, you can do that. Think of, here it is, there are both those parentheses, and here they are again, right there, and here they are a third time, right there. In this case, the x minus 1 will cancel with the first of the parentheses, and I'll get x plus 2 times 1. X plus 2 times 1. I didn't need to write it like that, but I'm just trying to emphasize it. Plus 3 times, well, the x plus 2 cancels with the x plus 2, and I get x minus 1. And then, like I said, these two both cancel with these two, and I get just the 5x in the top. So when I simplify this, I get then x plus 2 plus 3x minus 3 equals 5x. That's x and 3x is 4x. When I take away that from both sides, well, let me just group my terms. 4x then minus 1 equals 5x. Take away 4x from both sides, and I get negative 1 equals x. There's my solution. It always would help to plug it in and check and see if it works. I'm not going to spend the time doing that, but you can do that just to see if I did it correctly. Here's a quadratic. Fundamental concept from the first semester and the second is that when you see a quadratic, shove it over to one side, set it all equal to 0, minus 16 then equals 0. See if you can factor this. Two numbers that multiply to make negative 16 that add up to make positive 6 are plus 8 and minus 2. The only time this is going to be 0 is when x equals negative 8, or that's 0 when x equals positive 2. Brackets, though, don't put parentheses. Alright? So there's that solution. I guess I should be circling my solutions. This one is similar, only it's a cubic. This one back here was a quadratic. So I'm going to try to factor out a common term. I can't take a 4 out of 26, but I can take a 2 out of everything, so I'm going to do that. I can take an x out as well because I found an x in all of these. So what's left behind is 2x squared plus 13x plus 15 equals 0. And then can I factor this? This is the challenge. I'll quickly do the box method here just to review how that's done. I put 2x squared right there, I put 15 right there, and I multiply squared right there, and I bring that 30x squared over. So I'm looking for two numbers that multiply to make 30 that add up to 13. So multiplying, let's see, 10 times 3 gives me 30, so that makes sense. So this is going to be 10x and 3x. And there we go. So what we do when we get that factored is we look at this part here and we throw out common numbers, which is 2, and x's. So 2x squared plus 10x, I can take out a 2x and I get then x plus 5. So this is one, x plus 5, 2x then plus 3. And don't forget that 2x out here. Okay, so not easy to factor. You could put it into the quadratic formula if you wanted to. That's equal to 0 when x equals 0. This when it's negative 5. And this is equal to 0 when it's negative 1.5. Negative 3 halves. Okay, so there's your solution for that. That's a little bit